Hello, my name is Misaf Nemat Gorgrani, and this is my final project for Duke University for laying foundation of product managers. In this project, we should build a machine learning body model that will use four independent variables: temperature, exhaust vacuum, ambient pressure, and relative humidity to predict the expected energy output of a combined cycle power plant. To build this model, I have been provided a set of 9,568 hourly average environmental readings. The project objectives are to determine which machine learning approach best fits the scenario, which set of features should be used in the model, and which algorithm will produce the best outcomes in order to accomplish this goal. I will manually split my data, compare two different models selecting, and that achieves the best result and evaluate the performance of the final model. My first step is to get a better understanding of data and the relationship of the variables. To do this, I start by plotting each of the input variables or features against the energy output. There appears to be a strong linear correlation of some of the variables based on data visualization, number of features, and need for interpretability, accuracy, and efficiency. I have selected multiple linear regression. I have excluded lasso and read regression based on the number of variable and complexity I may choose to return to. These methods should multiple linear regression prove inadequate data will be split 18 to 20 between training and test data. Respectively, after running multiple linear regression on the training data consisting of 7,055 observation of rows, I observed that my R square is 0.92. 97, this represents this proportion of variables in my dependent variable that can be explained by the independent variable. In other words, how closely the energy output correlates with the environmental readings. The other observation is that ambient pressure correlates the less with the energy output. This for inform my feature. Selection for model A, I've decided to include temperature, exhaust vacuum, and relative humidity, and to exclude ambient pressure from the feature set of model. Feature set model B, I have included all features in the feature set: temperature, exhaust vacuum, ambient pressure, and relative humidity. I will use root mean square, mean absolute percentage error, and mean absolute error to validate my models. As you can see, I used Excel to run my linear regression. In this project, I taking a closer look at the result for model A. I have used 7,655 observation, which represent 80% of my total data. Set my R square is 0.929. My RMS is my RMC is 4541. My MAP is 0.797, and my MAE is 3. Here are the results for model B, run on the training data as well. Taking a closer look once again, I've used 7,500 observation, which represent against 80% of my data. My R square is 7.929, which is slightly higher correlation than model A. My RMC is 4.5. My MP is 0.7, and my MAE is 3161. Comparing the result of two models, we see that model B has a very slight advantage over model A. If I were to stop here, I would select model B as preferred model and test that model on the testing data. However, due to the small testing difference between the two models, due to a small difference between the two models, I decided to run both models on the test data to see if the same result running model A on the test data gives me similar result on a training data running B on the data also gives me slightly better similar result in training data comparing the two ones. Again, a constantly small difference between the two. Model having completed in additional stuff, I would model in real world example slightly improved. As model A would create in a summation of percent of additional information, I would select model B if accuracy is my only measure of success. Thank you.